For this problem, let's take a look at this power series, summation n equals 1 to infinity, 3n factorial over n factorial cubed times x minus 1 to the n, and we'll determine the values of x for which the power series converges absolutely. Now, for most problems of this sort, we also want to consider the endpoints to see if the series converges at the endpoints of the interval of convergence. However, this one, the problem explicitly states do not do this. And I put that caveat there because one of the endpoints is actually very, very complicated to study. And so that's more difficult than what I would expect on any exam. And so I'm not expecting that here. Okay, now this involves factorials, and so that rules out using the root test. So let's use the ratio test to determine the interval of convergence. So using the ratio test, we need to figure out the limit as n goes to infinity of, okay, now n, everywhere I've seen n, I replaced by n plus 1. So 3 times n plus 1 factorial over n plus 1 factorial cubed times x minus 1 to the n plus 1 over, and I'm taking absolute values here in a second, so sorry about that, 3n factorial over n factorial cubed times x minus 1 to the n, and I'll take the absolute value of this whole thing. And I want to figure out the values of x for which this limit is between less than 1. Okay, so let's write this out. So we've got the limit as n goes to infinity of 3n plus 3 factorial over n plus 1 factorial cubed times x minus 1. And I'll cancel those, right? Because n plus 1 over n, so I get x minus 1, the first on top, all divided by, on the bottom, 3n factorial over n factorial cubed. Okay, so limit as n goes to infinity. So I have 3n plus 3 factorial divided by 3n factorial. That accounts for these two terms. And then accounting for these two terms, I have n factorial over n plus 1 factorial, whole thing cubed. And I forgot the absolute value signs, I apologize, times x minus 1. Okay, now let's think about this. This first bit, we've got 3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial, all over 3n factorial. This is everything from 1 to 3n, then I multiply by 3n plus 1, 3n plus 2, 3n plus 3, and that gives me 3n plus 3 factorial. The next bit, I have n factorial. On the bottom, I have n plus 1 times n factorial, and that is getting cubed, times x minus 1, and that ends the absolute value. And so lots of stuff cancels on the next line. I get 3n plus 3 times 3n plus 2 times 3n plus 1 all over. So 3n factorials cancel. Over here, n factorials cancel, and I get n plus 1 to the third times x minus 1. Okay, now that's more palatable. Now this is now a rational function involving n, that this is a cubic function on top. If I were to multiply this out on top, I would have a 3n times 3n times 3n is 27n cubed on top. If I were to multiply this out, I'd have n cubed on the bottom. And so because I have the same degree on the numerator as I do on the denominator, I can cancel out the coefficients. And so this works out to be simply, well, now actually I don't need the limit anymore. I get 27 over 1 times the absolute value of x minus 1. So that's the value of the limit. Therefore, the series converges absolutely if this limit, 27 times the absolute value of x minus 1, is less than 1. In other words, absolute value of x minus 1 is less than 1 over 27. Okay, said another way, negative 1 over 27 is less than x minus 1, less than 1 over 27. And that makes x has to be between 26 over 27 and 28 over 27. And so if x is between these two numbers, which you probably would not have guessed at the start of the problem, then the series converges absolutely. Now, determining the convergence at 26 over 27 actually isn't all that bad. 28 over 27 is a bit more painful, and so we're going to ignore that for the purposes of this problem. And so we're not going to worry about the two endpoints.